to talk about optimizing cloud storage. But before we actually dive in, I'm going to present a little bit of a company overview to help our listeners frame exactly what is Greenhouse Data and what is it that we do. And then, of course, we're going to be diving right into the meat and potatoes of today's presentation of cloud storage. Greenhouse Data is headquartered in Cheyenne, Wyoming since 2007. And if you look at the date, that's essentially, before there was even the term cloud, we have actually been a hosting provider. We're a VMware service provider. That's the hypervisor stack that Greenhouse Data currently employs. We have facilities located all over the United States to provide that geographic diversity. This includes the West Coast to the East Coast, and we're also wind-powered. We're an EPA Top 30 partner, which means that from a technical organization perspective, we're in the top 30 corporations with renewable energy consumption. And that puts Greenhouse Data up there with, say, a Microsoft or some of these larger traditional cloud providers. Greenhouse Data is process and procedure driven. We're fully compliant, which I will touch on in a moment. And one of our key aspects of our business is to provide 24/7 live customer support. We have an initiative that's called 15-Minute Hear from a Human, which essentially says that no matter what the problem is, you can expect a solution to be provided from a human within 15 minutes. Greenhouse Data has 3 core competencies. Of those include cloud infrastructure, which is what the cloud storage objectives of today's presentation are, co-location, and then a wide variety of managed services that are able to augment your IT organization with operations. As mentioned, our data centers are located across the United States from the West Coast to the East. If one notes this particular graphic, it explains which services are available in which geographic location, with obviously cloud playing a part in every single one of those. Compliance is another key aspect as it relates not only to the Greenhouse Data organization, but to a lot of our clients as well. Specifically, there is a rigid set of protocols and procedures that have to be documented and audited every single year. This includes HIPAA compliancy, SSAE 16, and then additionally PCI, Certified B corporations, Sarbanes-Oxley, etc. So now we're going to actually move into the cloud storage conversation. And essentially, according to TechTarget, who surveyed a large number of significant organizations, 50% of those surveyed companies report using cloud storage, an average of 24% of their data in the cloud. And so what that essentially says is that cloud storage is having a very large footprint and it's growing. As organizations are faced with certain IT challenges and costs, specifically as it relates to hardware refreshes, this becomes a critical aspect to be able to leverage a cloud service provider for storage. Every cloud application requires storage, and some of the most commonly used applications are entirely storage focused, like enterprise file sharing and collaboration, and we'll get into a few more as we progress. First question that our listeners may be asking themselves is, how is cloud storage actually accessed? And there are a few key points which our viewers might be able to see. The largest and most prominent is the one thing that every organization has in common with a cloud service provider, that being the internet. And the internet, of course, is it's multi-protocol, and so there are various mechanisms to communicate with cloud storage. Some of the most prominent include HTTP, FTP, specific application ports or portals, and then also LAN network drives for those that need to extend over a VPN tunnel, which of course is CIFS and network file systems. Additionally, depending on the size of the organization, there may be the need for a very high degree of service level agreements where connectivity cannot go down, and therefore a point-to-point link would be appropriate. Additionally, if there is a very high data change rate or throughput required, a point-to-point link is often the direction that most clients pursue. One of the things that we're going to be talking quite a bit about today is the application protocol interface, or the API. And specifically, we're going to be talking about two, which were the RESTful API and SOAP. And both of those, of course, have to do with the unstructured or object storage protocols. Custom application integration is also a storage accessible option, as well as various virtualization platforms. And those platforms can be hypervisor agnostic. So how is cloud storage being used? Again, this is from TechTarget, and the largest two operational aspects of cloud storage are backup and disaster recovery. And this is typically something that we see from a cloud solution provider being a resiliency or an operational continuity. So therefore, data is not necessarily stored on premise. It's actually shared across what could be potentially multiple geographic locations, and therein protecting that data. Getting a little bit more deeply in there is the collaboration and file storage. So essentially, this would be just flat files like a network share. Archival, which is also, I might add, a growing aspect of how cloud storage is being used, simply for organizations that have data sprawl, where either this could be compliance driven, or it could be something internal where data is just accumulating, and of course that incurs a cost. And so being able to offload that storage mechanism to a cloud service provider becomes very attractive. Additionally, primary storage and nearline storage, also known as more or less local storage, for those clients that are actually in the cloud already. Let's talk about data. Data is experiencing an explosion right now. Essentially, we are seeing data is doubling more than every 2 years. And this makes sense if we think about it. The whole world is becoming digitized, everything from surveillance video to police body cams to traffic light signaling. There is a vast quantity of data, and it's becoming exponential. And a key driver of that is what is known as the Internet of Things. So more and more devices communicating all of the time with one another, and that data has to go someplace, and that becomes a critical driver of this. One of the things I'd like to point out on this particular slide is that the total data in the world is fast approaching 40 zettabytes, anticipated by the year 2019. That is an incredible amount of number. It's almost difficult to wrap one's brain around. And essentially, one of the things that's important is that on-premise hardware can often struggle to keep up with this data expansion, as more and more information is being generated, and also having to do hardware refreshes every 3 to 5 years. Capacity is often outgrown even before that, so there's an acceleration. That has a fiscal impact on budgets. And cloud storage is typically the easiest way to bolt on that additional capacity wherever it's needed. And legacy storage systems such as network attached storage, SANs, direct attached storage can actually struggle to effectively scale to manage data, particularly large data sets, where data, when I define data as being a large data set, we're talking about files that are approaching terabytes, if not petabytes in size, and also in number. So we're talking millions and millions of files. And that's simply where object storage comes into play. And object storage, being that unstructured data type, is that key delivery mechanism for storing data in the cloud. So let's talk about some of the cloud storage hurdles. The biggest is bandwidth. As mentioned earlier, the internet is something that all organizations have in common. However, those bandwidth pipes, particularly as they relate to perhaps rural areas where bandwidth is not necessarily available, can pose a significant challenge to an organization pursuing that particular direction. And that obviously can lead to significant costs. Bandwidth was also listed as a top concern by those companies surveyed by TechTarget looking to adopt the cloud storage. Security, capacity costs, and accessibility are all the other top issues. And as you combine different cloud applications, different types of storage might be better suited to each virtual machine or virtual application. And you don't want to transfer heavy backup files over the network repeatedly. So things like deduplication and delta data transfers become imperative in order to conserve that bandwidth. A lower cost performance application may not need as high as IOPS, which is the mechanism used to measure the storage speed, if you will, how fast the system can read and write data. And the content delivery network might operate more effectively using a block storage type of arrangement. And so a content delivery network can be thought of as, say, a Netflix or a video streaming service. And so that essentially data is located across multiple geographics so that it's closer to the consumer. As I'd mentioned, the various underlying technologies, all of these can be used in combination when we talk about cloud storage. Each is applicable to a certain strength, and also each incurs significant weaknesses where it may not necessarily be appropriate. The first, of course, is the direct attached storage, or DAS, And typically, that means that the storage system itself is physically connected to the server that it's actually being consumed on. The good advantage of that is that it's simple, it's dedicated, and it can often offer better performance depending on what that interface looks like. Next is the network attached storage, or NAS. These typically are like lightweight SANs that can be picked up very, very quickly, or easily, with so like a big box office retailer. They're connected typically via IP, hence the network and network attached storage, and they often provide a very simplistic file system for those storage to be accessed, notably CIFS or network file system. And they can also be dedicated to a particular workload or function of an organization. We have storage area networks. These are what the larger organizations typically refer to as either DAS, NAS, but these are the large storage arrays that are typically very high performance. They normally utilize some level of block storage. That block storage could be somewhat proprietary or a secret sauce, depending on which storage area network provider that is. And it can also be thought of as the data structures that are presented as either volumes or LUNs to a particular file system. Now let's talk a little bit about the differences in between each of these. So across the top, there's the column headings of file, block, and object storage. And understanding the differences between these become pretty critical because of how they're applied in a cloud storage environment. NAS and SANs, they typically, if you will, are file organizations. They're structured dependent on a particular operating system. So in other words, a volume needs to be formatted. The performance aspects, and the performance and cost here, I think, are two key metrics that we need to look at. Performance is often low from a file storage system. So you think of a hard drive on a desktop or local storage. Cost, however, is very low. This storage mechanism is commoditized. The price per gigabyte is actually decreasing. And particular use cases are long-term archives, development and tests, and then, of course, home directories from a particular organization or usage. The next column is block storage. And block storage is where we get into the more of the low to high performance aspects. The costs can range from medium price to ultra high price, let's put it that way. And typically block level storage is applicable for those, again, those high transaction, high performance applications such as databases, virtual machine storage, high volume exchange. And then again, if I'm a financial vertical, then the transactional elements of that. And then lastly, we have the object storage mechanism of cloud storage. And again, this typically happens via connector, which is the application protocol interface. It's a flat pool of reference data via metadata, so there's accompanying data that actually describes that data, and it uses objects as opposed to a particular file or block. The performance, however, tends to be on the lower side. So what we're talking about here is lower performance with the strength being durability. Cost is one of the key aspects of looking at object storage, and we see the cost factor going down dramatically in that particular delivery mechanism. Again, use cases such as content delivery networks, backup, disaster recovery. We start looking at big data where we have incredibly large data sets, and of course, archival. Next, we're going to talk about the software-defined storage, or SDS. And software-defined storage technology enables both the object and block or file level storage to be moved across virtualized environments, enabling portability, scalability, elasticity, vendor agnosticism, and the ability to reuse older commodity hardware as an additional storage device. Software-defined storage uses a virtualization layer to abstract available storage locations, separating the control functions from the physical storage. And what that means is that essentially an application can exist independently of a storage system. For example, if I'm a database and I know that I have an object that lives somewhere in unstructured storage, I would present a unique identifier. That goes over, and then by that unique identifier, that object or that file or that content can be retrieved. And this allows administrators to treat commodity storage blocks or even old servers and internal hard drives as a single scalable storage pool, reusable, from which virtual machines can pull resources. Again, we're using inexpensive hardware in this manner, which can lead to a 50% cost reduction while avoiding dependence on a particular vendor, at least on the hardware side. Some software-defined storage systems advertise 5 times the improvements in speed and performance as well, so storage administration time and costs are reduced. And thanks to automation features and orchestration improvements, this becomes a critical asset for organizations looking to get into what's called information lifecycle management. And I'll talk a little bit more about information lifecycle management in a bit. But touching on automation, this allows the software-defined storage to be dynamic. It can adjust, like basically sliding up a storage available to a virtual machine that has a sudden increase in read and write needs. This orchestration allows the administration to set up rules that extend that automation, like automatically enabling certain performance settings when a VM is cloned, or automatically placing backups in a lower performance tier. A term called I'd like to talk a little bit about that ILM a little bit more here. And essentially what ILM is, or Information Lifecycle Management, it's a sophisticated approach to automated data management, particularly as the way that data and the associated metadata is accessed or changes over time. And because of the different layers or tiers available in cloud storage, from high performance to low performance or ultra long-term compliancy issues such as archival, where you might even think of data residing in a cold state. And it's because of these differences in tiers that we are able to adjust the nature and frequency to be efficient, meaning that we can store and retrieve data as the data lifecycle commands as opposed to the storage system. And sometimes this is referred to as data flow, and depending on the nature of the lifecycle, more often than not, this will reduce costs. And I think having a use case example would probably be in the best interest, and I will touch on that here in a little bit. The next thing that is of critical importance when we're talking about cloud storage is durability. And durability is a measurement of the tiny errors that occur in files due to the underlying media. So think of a hard drive that as it ages, it suffers fatigue, and that of course puts data at risk, but it's very, very small. And when you read and write and rewrite, particularly gigabytes, terabytes, and petabytes, particularly on the same drive, one or more individual bytes may be corrupted over time. This is typically known as bit rot, and it plays on the laws of averages over literally very, very huge numbers. But it is there and it can pose a risk. And so for object storage, which is designed around storing massive quantities and content of file, especially media-rich files like images, video, durability becomes especially important. And again, once you reach petabytes, dropping even a single 9 of durability. And durability is typically measured in what we call the 5 nines or the 11 nines, so 99.999, etc. That level of durability plays a part. And that could, and just one difference of that could mean that we lose a couple bytes in the case of a large data set. And those couple bytes, depending on where they are, might actually pose a risk for data corruption. And in rare cases, this can lead to actual data loss if those bytes cannot be recovered. And one method of fighting the byte loss or the bit rot is what's called erasure coding. And when a file is copied to a cloud storage mechanism, erasure coding splits it up and adds an extra piece of that file that is a duplicate. So no bit resides in one spot. It's replicated across multiple physical drives. But when a single file is lost, it can be reconstructed from the pieces spread across that fabric to be able to reconstruct that. So instead of worrying about the number of nines, which is difficult to assess anyway, we look at erasure coding, which is similar kind of to RAID 5 or parity, as a method available to ensure the availability of data at all times. And erasure coding may not be available for all forms of cloud storage. Deduplication is another way that copies can be kept without storing duplication is another way that copies can be kept storing 2 complete duplicate versions of every file for every backup. Obviously, there's an increase of cost there. The system only copies the newly changed files and keeps the storage footprint down, so the level of changes that actually occur. And if the backup becomes corrupted, it cannot be reconstructed, unlike erasure coding. But a backup or file level storage is a good way to hedge your bets against data loss, having that duplicity. A full copy is also faster to restore than one rebuilt from erasure coded storage. So now let's talk about how to choose the storage. And when planning your cloud storage, The vital questions become, what type of storage is best suited for my environment? And can this data stand the reduced durability? Is there a cost to having some sort of bit rot or those risks that are associated there? And critical business data that's needed for daily operations should always have a full backup and preferably multiple backups in geographically separate data centers to avoid any sort of catastrophic loss. If your organization has a lower file volume, perhaps in the gigabytes or maybe even the lower terabytes, durability tends to be at least much less important, as losing a few bytes in corrupted files will be much smaller proportionally compared to a petabyte or an exabyte environment. So, who will access the data? This is another key consideration when you're starting to choose your storage. What type of devices will they use? Are they going to be using any sort of mobile devices? Some storage types cannot be accessed by that mobile device. What type of data is being created and stored? So we're actually looking, are we differentiating between video files and audio files and or database files? And so it's important to distinguish between the two because that plays a key part in choosing that cloud storage. And also, does the storage system need to work with your other systems? Either those that are on-premise if you're running a hybrid cloud deployment or other systems in other clouds as well. Additionally, what performance levels do we need? Is this intense like a high-frequency trading system, or can an organization get by with much lower input operations, such as like a SharePoint site? And it's all about finding that tipping point. When does an organization have too many files for the more traditional file system to handle, and when does an organization no longer need to access that document? So we're talking about that lifecycle management. And of course, cost is perhaps one of the largest major considerations, and a top performance tier of storage isn't, if it's not necessary, it's a nice to have. But there are significant cost savings that can be reduced or offset with monthly recurring costs by bumping down to lower IOPS, block level, or moving to an object storage platform instead, as we'll see in a couple use cases. And so I think this would probably be a good time to talk about that. So we're going to talk about the use case one, which would be a financial company. And so a trading company creates thousands of transactions every day, many of them automated, such as with high-frequency trading, and this plays a large role on today's exchanges. Finance companies' primary database is often stored in the block storage because it requiring very high IOPS, and this is also inclusive, notably with solid-state drives in order to be able to accommodate that extremely high volume. They require the performance as the automated transactions are happening in the milliseconds, so many transactions all the time. And a real-time tracking system watches the stock prices and must write and rewrite those records according for their compliance. And the frequently written files are not typically suited for other storage technologies, such as object storage, especially when they're accessed by users or different applications. So in other words, the number of users actually getting into these applications or using the storage system plays a part on which tier would be the most applicable. Once a transaction, however, occurs, a record is generated and it's kept in the block storage for a period of time. But close to, say, 80% of this data is infrequently or rarely accessed thereafter, except for maybe a compliance audit or some sort of an investigation. The SEC requires those records to be kept specifically for auditing, so organizations need to hold on to it, and this data needs to be protected, snapshotted, replicated, duplicated, which can, of course, incur significant costs for storage, network, and additional compute resources to be able to accommodate that. So the IT team sets up different storage policies to accommodate this. And essentially, to automatically move obsolete data based on the age of the data or the last date it was accessed. And older records are bumped to, say, an object storage pool for several years. Object storage, again, is that lower tier, and which balloons to large, but allows that organization to quickly answer in an audit call. In other words, data is protected for long-term retention. At the expense of performance, that durability factor comes into play. One of the side effects, however, is that retrieving that obsolete data from the object storage may take a little bit longer, but it no longer consumes the space on the higher tiers, which is the expensive block storage system. And additionally, one of the last steps that may even happen, depending on the organization, is there may be ultra long-term retention, such as even tape or something that fits at the bottom of this. The next use case is going to be a medical vertical example. And a good way to think about this is a traditional visit to a healthcare provider, such as a doctor. And so we're going to use a patient. We'll call him patient A or Joe for short. And so Joe comes into a large hospital, and he broke his foot mountain biking, and the doctor needs to take an x-ray. Joe's electronic health records, or EPHI, are stored in block storage because they're frequently accessed and modified when the doctor draws or makes notes on the images. Typically in a hospital arrangement, multiple people are accessing those records all of the time. And so for the first 2 months after his surgery, various specialists have to check in on that. And so that data lives in a high-performance tier of storage. So the specialists are looking at Joe's x-rays against the new ones just to make sure everything is healing, and the ability to pull it up quickly becomes very important. And nobody wants to wait around at the doctor's office, and doctors don't want to wait around on computers or storage systems, and so that performance tier becomes very applicable. After Joe's all healed up, the file from his x-rays are automatically moved into an object storage pool for archiving, and it can still be retrieved. However, the health provider is not paying a premium for that faster block storage. Again, this is information lifecycle management to either have a storage system itself or a third-party data management product migrate the data from the faster tier of a storage, which is more expensive, to a slow, durable tier for that longer-term retention. And because these are health records, that retention period often exceeds 7 years. And this efficiently utilizes those storage tiers based on the need and speed of access to the data, how that data ages, if it's current, and although it may still be used as part of a patient history. Typically, x-rays as well as other EPHI does not simply go away once the visit is over or the treatment program. So getting back to our example, let's say that Joe, a few years later, breaks his other foot. And that's essentially pretty bad luck for Joe. But instead of visiting the hospital this time, he goes to a small practitioner. And the small practice is part of a local network of providers where EPHI is typically shared, so say like a physician's network. And prior to his visit, the local practice would actually retrieve his medical history from that physician's network, including the x-rays from the hospital. Since time is not of the essence here, Joe's x-rays are typically retrieved from the object storage, so out of that slower tier pool, which can take upwards of a few hours depending on what that pool looks like. And then those images are in turn added to the local practice's patient's record system. So those images are actually duplicated from object storage into the local practices. And however, the smaller provider has fewer doctors and patients, so they may not actually have the sophistication of say, information lifecycle management that a large provider would have access to, and they may retain their images into perpetuity on their storage system, which would typically be like a mid-tier system, if you will. Again, there's a smaller cost footprint there, and as it relates to how data is stored, again, it's about the frequency and accessibility of that data. And so this example shows that storage is scalable depending on the needs of the organization, depending on what the performance looks like, depending on the number of users, and depending on the retention period. We're able to marry up different tiers of storage with different cases in that life cycle. One of the other things I'd like to touch on before we go out for questions is additional use cases. And as we look around, we've mentioned that there's a data explosion coming on right now. One of the key drivers of that happens to be video. And not only the video standards itself as resolutions increase from 4K to 8K, what used to be traditionally small file sizes are now growing large and ultra large. Additionally, there could be examples such as the police body cams that are now becoming much more mainstream in local police departments. All of those cameras have to capture information, and that data essentially could become evidence in a case at some point or an investigation, and so it needs to be preserved. But when you start scaling out the number of cameras, one per officer and then also one per squad car, that data or content increases exponentially, and so we see that. And that's where when we start looking into that durability, meaning that we can't have key footage being subject to bit rot, we need to look at those alternatives to be able to, in the storage realm, to be able to accommodate that. Additional use cases are managed service providers such as Greenhouse Data and also the cloud providers, where infrastructure as a service and software as a service becomes critical. And again, what we're talking about is large quantities of data that can span, quite a duration in time. I mentioned before the content delivery aspects, such as social media. If you're acclimated with Facebook and its ability to be able to capture images and share images, that is stored on an unstructured object storage platform. And again, it's scalability. We have millions and billions of users all submitting pictures, perhaps at the same time, and that has to be kept and stored. And then lastly, big data comes into play, where you're dealing with just tremendous data sets, such as in the realm of atmospheric sciences and weather research, where we're actually tracking many, many variables over long periods of time that we are able to go back and assess later. And with that, I'd like to open it up to questions from our listeners.
Hey, Steven, I've got one that came in here, and they're wondering if they would be charged each time they access their stored information, and if bandwidth charges are also incurred.
That is a great question, and it depends on the service provider. I can tell you that some of the largest service providers will charge for not only the transaction but the bandwidth as well. As it applies to Greenhouse Data, one of our value addeds, if you will, is that we do not assess to ingest data. So you can actually write data. There is a slight bandwidth charge that's built into the cost of that, so it's not ancillary. You're not going to see any surprises on your bills, and we do not have a transactional rate as well, so it's much simpler than some of our largest competitors.
Thanks. If anyone else has any questions, go ahead and toss them up via the question or the chat here. If not, thank you very much for joining us. We'll wait just a couple minutes in case, but if you need to hop off, we'll be sending out a recording of this webinar as well.